Hello, here's the second episode of The Secret of Water Insights, the water molecule H2O. These insights will be always published on Thursday, usually the first 3 Thursdays every month. This second episode is kind of theoretical and we will jump right into it. The atom is described as, with two models in fact, or all this atomic world. On the one side, the particle model, where there would be a central part and then the electrons flying around this central part. And the second model is more the wave model. I would more describe it as a pulsating energy model. And if we look now at the particle model, even there most of the whole structures or elements or materials is voids, nothing, space, 99.999999%. Many experts agree there are no particles. Everything is pulsating energy. I will be moving on this concept from now on the concept of waves, or rather vibrating energy. Every atom has its own specific frequency or vibration. I will go more into detail in later editions. The higher the frequency, the higher the specific weight, the denser the element. The hydrogen, as the lightest of all atoms, is vibrating the slowest. And then if you look at the oxygen atom, it is exactly 16 times heavier than the hydrogen atom. If you would describe them as a musical note, hydrogen and oxygen, they are the same note. Oxygen is just 4 octaves higher. So from that point of view, they fit together extremely well. More on this also in a later episode. Here if you look at this water molecule, it's a very, very, very small molecule. It's got the size of about 0.275 nanometers, which is 1 millimeter divided by 4 million. This water molecule is a so-called dipole. Why? Because its charges, the negative charges, the electrons, they are pulled rather to the heavier oxygen in the center of this V, and therefore you in average always find more electrons and a negative charge on this part where the oxygen sits, and more a positive charge on the two ends of the V where the two hydrogens are sitting. So these are clearly dipole properties. These little water molecules, they all are very reactive of anything electromagnetically happening in the environment. Let's look at this experiment by a German professor, which you can find on YouTube. When he charges this plastic stick by rubbing across it, so it will be negatively charged with electrons. It will have a static charge, in fact. And you see what happens when it is held towards this water coming from the outlet. And something really specifically unique of the water molecule is also the so-called hydrogen bonds. The water molecules, they stick together, as you see here in this model, where the plus sides, the hydrogen sides of the water molecule are attracted by the minus charged sides of the oxygen and build so-called hydrogen bonds, which makes it a liquid where in usual normal chemical rules in our ambient temperatures it would already be gaseous, but it is still liquid, and this is really important for life. Yeah, if you look at the cluster models which were shown in the movie in 2004, are they still useful cluster models? I would say they are still useful in that sense of looking at cluster models, water cluster models. There's nothing really new, groundbreaking that has been found. More on that towards the end of the episode, where we'll be looking at newer cluster models. One main reason why all these models are still theoretical and not really proven by experiments is the water molecule is so small. If you take the tip of a pen here, or there would be billions of water molecules just in this little tip.
When a foreign substance enters the water, the molecules, or rather these clusters, wrap themselves around it. They envelop it.
We will be looking at the most common salt, which is the table salt, which consists of sodium and chlorine. They form, as you see here, a very rigid crystalline structure. The sodium, as always electron missing, has a charge of 1 plus. Chlorine has always one additional electron. It is charged negatively. So they stick together with so-called ionic bonds. Yeah, if you look at this image here, of course, when the water gets close to a negatively charged chlorine, the plus parts of the water molecule will be looking and directed towards this chlorine. And when you have enough of these water molecules, they will pull this chlorine out of the crystal structure. They will dissolve it, and it will be afterwards be part of the water. On the other side, if you look at the sodium, which is also positively charged, there you always have the negative side of the water molecule being directed towards this sodium. And they're also the same thing. When there are enough of these water molecules, they will pull out the sodium and it will be dissolved in the water. So the water can dissolve quite a bit of this salt. It is, as I remember, about 32 grams per liter of water. This is, again, a liquid water. Of course, it's salty.
Anyone who wants to improve the quality of our drinking water must first understand what this basic substance consists of, because nowhere in nature is there pure H2O. Water is a unique solvent that almost greedily absorbs all substances it comes into contact with. With infinite patience, water dissolves mountains of limestone or even granite, a phenomenon. Depending on the original rock, the aqueous solution has a different quality.
Of course, other elements also play a role in this process. For example, how much oxygen or how much CO2 is in dissolved form in water, which makes the water a little bit more acid, and this helps dissolving these minerals. So let's look at the memory of water, and there, first of all, we'll have to be talking of the fact that everything can be expressed as electromagnetic waves or electromagnetic vibration or electromagnetic radiation. In nature, usually this radiation and these vibrations are very, very subtle, very, very fine, and always in a harmonic ratio in living organisms. The technical radiation is much stronger, and compared to these very harmonic structures in nature, these radiations, they are chaotic. No one has thought of adapting them to the natural vibrations. We've been looking at this in a specific work. You can also find the link on my homepage. In fact, they are exactly as off as it can get, and they will always distort the natural harmonic vibrations. Now, if I look at the memory of water, and I get in what Emilio Del Guidici said.
Whereas in solid substances, the atoms are in fixed positions. In liquids, this structure has a rhythmic form, as in a dance. This means that the arrangement in a liquid is not spatial, as here, but temporal.
These dissolved ingredients in the water, together with the water, they form so-called coherent fields. More on that also in one of the later episodes. When you have smaller clusters, you have more surface. Think of let's say a big ball, which is a huge water cluster. If you cut it in half, there where you cut it, this surface where will be a disposal in the outside, so we will have more surface at the outside, and this is really, really, really important, because if you look at this image now, in the inside there, these water molecules, they are not active. They will not be able to, for example, dissolve and carry salts inside the water itself. Only above there, these charges which are on the outside of these clusters, these plus and minus charges, they can be active, they can dissolve minerals, they can transport them all the way where the water is flowing. The smaller the water clusters are, the more you have electric charges available, which will increase the capacity of the water to hydrate. Yeah, I said I will be looking at cluster models. How does it look now in 2025? When I'm looking at newer publications, of course, newer cluster models have been found, but they all still remain theoretical. And the researchers which are making trials to find out about these structures, these trials are not representing reality, at least not water in nature. It might be helpful for some very specific technical processes like nano products, but for most applications it will not be helpful. Let's look at some of these models. Byung Kim, he presented in 2019 a model of water clusters and declared that they are chain-like, and he based his model on an observation of forces, pulling forces. He developed his model basically on these results, and he extrapolated it into natural things happening, which other publications would disagree with him. Let's look at that. Here we have a publication from June 2025, where, amongst other things, in the abstract, it is said that the electromagnetic configuration is a spatial arrangement of charged sites within an adsorbent can profoundly influence the adsorbent's interaction with the water and the resulting cluster formation and their orientation. Yeah, another publication from August 2025, very recent. The structure and properties of water in nano-confinement can differ significantly from bulk water, exhibiting, for instance, modified hydrogen bonds, altered dielectric constant, and distinct phase transitions. And when he talks here of bulk water, already one little drop of this water is bulk water in the context of making trials and experiments on a nanoscale. Yeah, what are the final conclusions of today's episode? First, water cluster models are all theoretical. Water molecules are too small to prove these models with experiments. 2. Smaller water molecules offer more charges and are able to carry more ingredients, salts typically. If you want to assimilate more magnesium, for example, then this energized water can help you. Of course, other factors like what happens during the process of digestions, for example, also play an important role. 3. If we have smaller water clusters, then the water has more energy, and this gives us the more precise definition of energized water. First, energized water is a water that has an average smaller clusters than a not energized water and therefore offers more electric charges at disposal. Secondly, an energized water usually has a more regular water quality by more regular cluster structures. Yeah, this episode was somewhat going into a very special topic. The next video coming out on October 2nd will start with the basic information on water so you can build your knowledge step by step. Please leave comments what you like to hear from. Where you don't agree, I prefer getting wiser over being right. Have a great day.